All right, so you're a food scientist, and you're probably thinking, what's next? How do you move beyond the bench and start, really engineering the future of food? Well, if that's you, you are in exactly the right place. In this explainer, we're going to lay out the complete roadmap for upgrading your career by learning to code with Python. Let's get into it. Okay, let's start with what is probably the single most important idea in this whole thing. This is not about leaving food science behind to become a coder. No way. It's about amplifying what you already know. Your deep understanding of chemistry, microbiology, and processing, that's your superpower. The code, that's just the tool that's going to let you use that superpower in some pretty incredible new ways. Exactly. So think of it as a powerful career upgrade. You get to be the coder in the lab coat, the one expert in the room who can fluently speak both languages, the science of food and the logic of code. And believe me, that combination is unbelievably rare and super valuable. Now, every great building needs a solid foundation, right? For us, that's phase 0. This is where we're going to spend about 4 weeks just mastering the absolute fundamentals, the basic building blocks of programming. The main goal here isn't just to learn syntax. It's really about a mental shift. It's about learning to think in terms of logic and sequences and automation. We're going to take concepts you already know inside and out from your day job and just learn how to express them in a language that a computer can finally understand. And here's the cool part. This stuff is instantly practical. This isn't some abstract, boring theory. You're learning to use variables to store a recipe's ingredient list. You're using if-else logic to write a simple safety rule, like if the pH is below 4.6, then the product is safe. Or, and this is a big one, using a for loop to automatically process the data from 10 different batches without ever having to copy and paste again. And by the end of this phase, you'll have built your very first real tool, a command line recipe scaler. Just imagine that. No more calculator errors when you're trying to scale a formula from a tiny 100-gram bench sample to a massive 1,000-kilogram production run. You will have built the program that does it for you, perfectly, every single time. Okay, so our foundation is poured. Now it's time to start building something really powerful. In phases 1 and 2, we start using code to analyze the data you already have, and, maybe more importantly, to start predicting future outcomes. So there's a really crucial shift in perspective here. Think of it like this. Phase 1 is about looking backward, taking all that lab data you've painstakingly collected and finally analyzing it efficiently. Phase 2, well, that's about looking forward, using that data and scientific principles to build models that predict what's going to happen. So in phase 1, I want to introduce you to your 2 new best friends, Python libraries called pandas and matplotlib. Think of pandas as like Excel on steroids. It lets you sift through huge nutritional databases in just seconds. And matplotlib, oh man, you can kiss those soul-crushing hours clicking through Excel menus goodbye. It can plot a dozen shelf life curves from your stability study automatically. And your milestone project for this phase? It's a massive time saver. You'll actually write a script that takes your raw lab data, generates all the degradation plots you need, and even automatically flags any samples that are trending out of spec. This is automation that has a direct impact on your product quality. Now let's jump to phase 2, where we build on that. This is where we get into real-deal process engineering. We're going to use Python tools like SciPy to model the actual physics and chemistry of our processes. Things like calculating the F value for a pasteurization system directly from heat transfer principles. And the next milestone is a biggie, a full-on thermal process calculator. You'll build a tool that takes your product's properties, your process parameters, and tells you if you're hitting a safe microbial kill step. You'll be applying FDA and USDA logic right into your code. This is a huge leap from just analyzing data to actually engineering for safety. Okay, we've mastered the lab data, so now in phase 3, we're going to take these skills out of the R&D center, put on our hard hats, and bring them right out onto the production floor, building real tools that help real people do their jobs better. The goal here is simple, but so powerful. You're going to find the tedious, repetitive, error-prone jobs that operators and QC techs have to do every single day, and you're going to build a tool that does it for them. You'll basically be a hero, freeing up their time and mental energy for more critical thinking. And this is where your code makes a direct, visible impact on the business. You'll learn to use tools like Streamlit to build a live dashboard that shows QC data in real time as it's collected. Or, and this is a huge pain point for so many people, just imagine completely automating the generation of a certificate of analysis. The second the final QC checks are in, boom, your program creates the official PDF and saves it. No more manual paperwork. Done. The capstone for this phase is the whole shebang, a complete digital HACCP logbook. It's an interactive app where operators can input their critical control point data right on the line. It'll instantly flag any deviations, create a permanent digital record, and export compliance reports with a single click. You see? You're not just a scientist anymore. You're building the very systems that ensure food safety. Okay, so after building this incredibly strong and versatile foundation, the final phase is all about specialization. It's about choosing the path that really lines up with your career goals and your passions. Think of it as a choose-your-own-adventure. Do you love the energy of the factory floor? Then you'll dive deep into process and manufacturing engineering. Are you fascinated by discovery and finding hidden patterns? Then the food data science track is your jam. You could use machine learning to predict sensory scores. Or do you want to be the master of compliance? The regulatory and quality systems track will have you automating things like traceability and nutrition labeling. So, what do you think? Feeling inspired? Ready to actually start building? Well, here's the best part. You can begin this journey the moment this explainer is over. There are absolutely zero barriers to entry. You only need 3 things to get started, and they are all completely free. First, you download the latest version of Python. That's the programming language itself. Second, you grab VS Code, which is your code editor. Think of it as your digital lab bench. And third, get an AI coding assistant like Claude Code to help you along. That is it. That is everything you need to start phase 0 right now. So I'm going to leave you with this one question. When you're at work tomorrow, look around your lab, your plant, your desk. What is that one manual, repetitive, mind-numbing task that you wish you never had to do again? That is your starting point. That is the very first problem your new skills as a food engineer are going to solve.